Hey guys, uh, um, hey guys, welcome back everyone. Can you hear me? Hello.
Yes, sir.
Uh,
Yes.
Thanks. What's happening? Hmm, what is happening? Okay. Mhm.
Hello.
1 minute. Uh, 1 minute. एक minute. It's fine now. Okay. And just okay. So guys, I'm going to start from a very basic that I just want to know, like you must just have a basic knowledge of what is IP address, right? And what is MAC. That's it. Okay. I assuming that you just have this knowledge, like what is IP address, what is MAC. I'm going to start from very basic, right? Okay. Someone, I guess. So guys, if I'm going to talk about a very simple scenario, take example, there is a one guy over there, right? And this guy is present into the Delhi locations. Okay. Just try to understand the very basic. This is a very basic important concept, right? So this guy is belong to the A. This guy name is A, and A basically belong to the Delhi location. So I can just write and this is the Delhi, and I send this Rohini, right? So this is the location of this is the cities, and in the cities we have some areas, right? Same thing, we have another person over there in different locations. For example, this guy B is sitting in the Bangalore. Okay, so this guy is sitting in the Bangalore, HSR. Now try to understand.
Hello, sir. Sorry to interrupt you, sir. Your voice is not audible, sir.
Everyone is facing the same issues. Hello.
Yes, sir. It's breaking.
Okay.
Is it audible?
It's audible. I think so. My side is clear, I
Hello,
guess.
sir. Your voice is not audible, sir.
Again, network issue.
1 minute. Because drops are not there. Okay, delay is happening. Okay. 1 minute. This is full now, right? Now can you hear me? I'm audible.
Yes, sir.
Okay. So yeah.
Yes.
No, sir. Not audible, sir.
Still not at all.
Your voice is tracking, sir.
No, everything is fine from my. I think so. Your side issues, buddy.
It is
Hello.
audible.
It's audible. Ujjwal, I think so. Your side issues there. Check your side.
Sir, it's audible.
Sir, now it's audible, sir.
Okay, perfect. Okay.
Hello.
Okay. Yeah. Hi. Hello.
Hi. So I just wanted to ask, can you do an introduction of yourself, please? Because I'm new and it's
Oh,
day one for me.
okay. 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 My name is Lokumar Shah, and I'm a CTS certified. So basically, I'm from Jaipur, not Jaipur. I did my BTech from Jaipur, and I'm basically from Bihar, living in the Bangalore right now. You can call me
Okay.
Lok. That's it.
Okay.
Fine.
Great. Yeah.
So
Thank you.
okay, thanks. So there is a guy over there A, and this is the guy B over there. So they are living in the different locations in the Delhi, and this guy is living in the Rohini over there, and this B is living in the Bangalore HSR layout. Okay. So take example, if this person, right, if this person wants to send some message, for example, this guy has purchased the one phone. Okay, so this is the phone they have purchased. So what happened? This guy has to send this phone, or this guy wants to give something to this guy. So what happened? They first of all, this guy has to put this phone into this box. Okay, let's do one thing. Let me make a small size. So this is the phone, and this guy who save this phone wants to sell this phone to the B. So what happened? First of all, this guy has to put this phone into this box. That is called as a encapsulation, right? And after that, what happened was this guy will put this phone into this box. Now this guy has to save this phone to the one courier guy. So this guy has delivered this phone to the courier guy. Now what courier guy will do? They will send this information to the B. Now try to understand one thing over there. In this box, what information this guy will write over this? A, he will write the source information that is coming from the Delhi, and this is the Rohini over there. And destination they will put over there, Bangalore. Right? And it will put the HSR layout over there. Try to understand one thing, right? Try to understand one thing. Right now, this A has put the complete information source Delhi Rohini and destinations of Bangalore HSR layout. Now, what this guy will do, this courier guy will deliver, right? This courier guy will deliver this box to the B at the correct location because we are putting all the information in this packet. Right? This is how something will happen. Now take example, what happened if I'm not going to put the HSR layout? If I'm not going to put the HSR layout, same thing, what happened now, the A will give this courier box to the courier guy. And what courier guy will do, once this courier guy will receive this information, what they find over there, okay, source is Delhi and Rohini, but what is the destination happening in the Bangalore only? So what courier guy will do? They will just drop the packet. Because this guy is not able to determine where actually B is present, right? Guys, just pay attention now. This is a very interesting topic right now. The B is not the courier guy is not able to determine where is exactly B, because in the Bangalore is a very big, right? Where is the courier guy will find in the where is the B in the Bangalore? You have to put the complete information. You have to put the complete information. So if I'm going to correlate with the networking, right? If I'm going to correlate with the networking, what happened? Can you go a bit slow or louder? Your voice is very slow. Okay. My voice is good. I can go a bit slow, but my voice is, I think so, it's good. Okay, no issue. So what happened now? So this Delhi, if I'm going to correlate, this Delhi is like your IP, right? And your Rohini is like your MAC address. Same thing in the Bangalore side. Hello. Same thing in the Bangalore side. What happened? This is guy is a IP, and the HSR layout is what? Is a MAC address. So what I'm trying to show you over there, guys, a packet, right? A packet has a complete information. A packet must have a complete source MAC address. They must have a destination MAC address. They must have a source IP address, and they must have a destination IP address. If you have a complete information source MAC, destination MAC, source IP, and destination IP, then your packet is complete. This is called as a complete packet. But right now, what happened? This A did not put the HSR layout. So this packet is incomplete, right? So in this case, what happened? This is something like this packet is happening. Source MAC will be A. Destination MAC is what? I didn't put over there. Source IP is what? 10101. And destination IP is what? 10102. So IP is your Delhi, right? So they put the Delhi. At the same time, they put the destination Bangalore. Source MAC they also put, but destination MAC is not there. This is called what? This is called as a incomplete packet. So if the packet is incomplete, what your networking device is going to do? They will simply drop. Simply they will drop the packet. And this is the point, right? This is the most important things that you have to understand over there. Because many times in your interview, right, they will ask you this kind of scenarios. So basically what happened when I'm talking about, like, if I'm going to correlate with the networking, a PC1, take example, this is a PC number 1, right? And we have another PC number 2, right? 1 minute. PC1 and PC2. So the PCA and PCB. The PCA has a own information we can write over there. This is the IPs. So the IP of this guy will be a late P information. The MAC will be A. Same thing, the B has a IP address 1.2 and the MAC will be B. And now I'm going to connect the wire media, because right now we are learning the wire technology, not the wireless. So if you want to share the any information, for example, this A wants to share any information to the B, right? And B wants to share any information to the A, right? Any information, we need to have a one media. For example, if you want to drive your car, you must need to know where is the road, right? If the road is not there, you cannot drive your car, right? If the road is not there, you cannot drive your car. So road is what? Road is like your wire media. Road is like wire. And if I'm going to talk about the plane is what? It's a wireless. Like what? You're driving your plane in the air, right? Not the road. So right now we are learning the technology is called as a wire. We need to have a wire, right? And through that wire, I'm going to send the information. If you're going to learn the wireless technology, in the wireless technology, what happened? There is no need of wire. No need of wire. You can directly share the information through the Wi-Fi. But right now we are learning the concept of the wire media. So must need to have a wire technology. So now we have a PCA and PCB. The PCA has its own identification over their IP, and this is the MAC address. And the PCB has its own identification of the 102, and they have a MAC address B over there. Now, I just want to, before exchanging any data, listen to me very carefully. Before exchanging any data, I first need to check the connectivity. Like whenever you're making a call, for example, this is my number, right? And whenever this is log and you're going to make a call to the log, what happened? First of all, you say that hello, right? What is this hello? And also the log will say the hello, right? What is this hello? Hello is just you, like, it's just check your connectivity. Hello is what? If this guy will send if A is there and this is the law, and so if you make a call to the law, what happened? First you need to extend the hello, right? And what hello is going to do? It just check your connectivity. If you have a connectivity, right? If the hello will be exchanged, after that what happened? You can exchange the data as well. Whatever the information you have, you can exchange it. Same thing happened with your networking. If you want to share any information from the PCA to the PCB, first of all, what happened? You need to check the connectivity, right? And how do I check the connectivity? By using a command that is called as a ping. So ping is what? Guys, ping is a command, right? Ping is command that works on ICMP protocol. Ping stands for packet internet. So ping is what? It's a command that works on the ICMP protocol. Ping stands for packet internet. So by using this command, what happened? I can check the connectivity from the source to destination. So what size is the ping? 101 or 2? What happened? I'm pinging to whom? I'm pinging to layer 3 information. That's the IP address, right? So in that case, what happened? What PC1 will do? This guy will create a packet, right? In this packet, what information I will have? I will have a source MAC, right? You will have a destination MAC information. Then you will have a type field, right? Then you will have a source IP information and destination IP information. So in the source MAC, source MAC we have destination MAC information, we have a type field, we have a source IP information, and we have a destination IP information, right? This information, when I say the ping 102, the PCA will create. In the source MAC, what happened? I can put the own MAC address, right? Yeah, because I know my own information, right? So I can put the own MAC information A over there. Source IP, I can put the 101 because I know myself, right? And I'm sending the traffic to whom? Ping 102, right? So I can put the destination IP is what? 102. What I'm going to put the destination MAC? And type field, I'm going to put the 0x. I'll explain it to this type field. Don't worry about that. 0x0800. No, in the destination right now, the PCA does not know about the destination MAC, right? Because always, whenever you're trying to send a traffic, what happened when you use the google.com, right? On a Google, what happened? You're trying to write www.google.com, right? That's you are typing. Are you typing the like a MAC address? No, actually you are typing the IP addressing, right? In the background, actually you're sending the IP addressing. When I say the command prompt, what I'm sending over there, I'm saying the ping, right? 8.8.8.8. Am I sending the traffic to the MAC address over there? I'm not sending the traffic to the MAC address. I'm sending the traffic to the IP address. So I don't know what's a MAC address of B over there right now. I don't know what's a MAC address of B. I'm just know the destination IP address 112 because I'm sending the traffic to the 112. So in that case, what happened? This is called as a ICMP request packet, right? This is called ICMP request packet. And what this request packet will do, the PCA itself drop this packet. You know why they will drop the packet? Just because of the encapsulation failed. Just because of the PC1 dropped this packet at this point, right? Encapsulation failed. This packet has dropped. Same example of this one, right? This one, incomplete packet, right? We are not able to fulfill the complete information. The source in from Delhi and Dhoni and the distance in Bangalore, we didn't put the HSR layer, right? So if you're not going to put the HSR layer, what courier guy is going to do? They will just drop it. You need to define the complete information. You need to define the complete information over there. PCA does not know about the MAC address, right? So in that case, what happened? This ICMP request packet, the PC will drop at the this end, not to the this end. Many times, this kind of question they will ask you in the interview, right? Tell me, if I'm going to ping from the PCA to the PCB, where will be the packet drop? Where will be the packet drop? What person is saying that the packet will be dropped at the switch end or maybe at the receiver end? It's never like that. The packet itself drop on the PC. Because this is not a complete information. This is an incomplete packet. This is an incomplete packet. In that case, what happened? Why I'm dropping the packet? Because this destination MAC is not there. So I need to bring a one guy, and that guy name is what? That guy name is a ARP. ARP stands for address resolutions protocol. Try to understand. I'm going to resolve, right? I'm going to resolve the address. What address I'm going to resolve? I'm going to resolve the layer 2 address by using a layer 3. Layer 2 address means what? I'm talking about the MAC address. Layer 3 information, I'm talking about the IP address, right? So I'm going to resolve the layer 2 address by using the layer 3. And who will help this guy? The guy will help the ARP protocol. So in that case, what happened? Now the PC1 itself generating a our packet. So this will be our packet over there. So in that case, what happened? We have a Ethernet header, right? And after that, we have a ARP header. And in this Ethernet header, we have a source MAC information. We have a destination MAC information at the same time. We have a type field. Come on. In the ARP header, then we have a source IP information and destination IP information. So now the source MAC will be what? The source MAC will be still A, right, in the Ethernet header as well as, and the ARP header as well as, right? So Ethernet header, the destination MAC will be what? Because now this is the what? This is the ARP request packet, and I'm looking for what? I'm looking for a destination MAC information. The PC1 is now looking for what? Destination MAC. Which person MAC address? 1.1.1.2 MAC address. Right? So, exactly. So what happens? The destination MAC will be over there, FFFF layer 2 broadcast address. This MAC address is called as a layer 2 broadcast address. MAC address. Right? After that, ARP request Ethernet header will be what? Now we have a 0x0806. The source, and now the here the ARP header will be your destination MAC. Destination MAC will be 000 because I don't know. Right now I'm requesting, right? So that I don't know. In the ARP header, what happened? We have an IP over there that is called as a 0x0800, right? And the source IP will be what? 101.1. And destination will be what? I'm looking for the MAC address of this PC. Now the PC1 is going to generate this ARP request packet that is always do the broadcast. And what PC1 will do, now it will send this packet to the home PC number. And this this packet is called as a ARP request packet. That always do the broadcast. Guys, pay attention. It's very, very important topic because if you don't know this part, there's no sense to do the networking. Now, once the PC number 2, right, PC number B will receive this packet, right? What PC number B will do first of all? By default, every PC maintained, right, ARP table that contains the information about IP to MAC mapping, or we can say layer 3 to layer 2 mapping, or we can also call as a 32-bit address to 48-bit address map. Why I'm calling it call as a 32-bit? Because your IPv4 size is a 32-bit address and your MAC address size is 48-bit address. So whatever things that you can call it, call it. So this PC has a ARP table, right? And even this PC also has a ARP table. So once this packet, right, once this ARP request packet reach to the PC number 2, what PC number 2 will do this packet, right? I'm talking about this packet. PC number B, first of all, they will update the own ARP table, right? He said that, okay, 101.101.1 associated with the MAC address. This is the IPC information, and we have a MAC information, IP, and this is called as a MAC. They will learn the source information, this source information and this IP. After that, what? The PCB said that, hey, someone, right? Someone is on 101.1 that has a MAC address A is looking, right? Is looking the MAC address of me. Someone that is 101.1 is looking the MAC address, right? 00, because the distance of MAC is what? 00, because they don't know about the MAC address of me, right? So he's requesting the MAC address 101.2, that's me. He's requesting the A is requesting the MAC address. So what happened now? The PC number B will create a ARP reply packet. And in this ARP reply packet, what happened? We have a source MAC, we have a destination MAC information, we have a type field, we have a source IP. I'll explain you type field, don't worry about that. And this is the source MAC will be what? Now the PCB is sending, right? So source MAC will be B, right? B, destination MAC will be what? Now I will create a unicast packet because now the B will look up, hey, A is present in my app table, right? So destination MAC will be what? A, destination MAC will be what? A, the type field will be what now? 0x0806. Here will be IP, the type will be 0x0800, and then after the source IP will be what? 102 because I'm sending to whom? 1011. And how do I get this 1011 associated with the MAC address A? Sorry, MAC address A based on this information. Because whenever the PC will send the packet, right? Whenever the PC will send the packet, they fetch the layer 2 and layer 3 information from your app table. So now we have a complete information. Now what PCB will do, it will send the reply packet to whom? This is called as a ARP reply packet, and they will send to the PCA. And this will be a unicast packet. Why I'm going to call this guy as a unicast packet? Because this packet has a complete unicast traffic. B MAC address, A MAC address, IP also unicast. But in that case, what happened? If you see, we have a destination MAC address is what? Broadcast. That's why I'm going to call this guy as a broadcast packet. Here, all we have a unicast thing. Even the IP addresses and the MAC addresses, everything is unicast. So that's why I'm going to call this guy as a unicast. Basically, you have a 3 types of traffic, right? If I'm going to talk about the types of traffic we have 3 types of traffic. Either it can be a unicast, it can be a broadcast, and it can be a multicast as well as. I'm not going to talk about the anycast. If you have an idea of the anycast, it's good. If you don't know, forget it right now. I don't want to make you confused right now. Unicast means what? One-to-one communication. Like you are making a phone call, right? That is a one-to-one communications. Broadcast means what? One to all. That I'm sending the message to everyone, right? That's called as a one-to-all. One-to-all communication is known as a broadcast. And then we have a one-to-many. A very good example of one-to-many is your WhatsApp group. Because I'm just sending a message to the particular group, right? Not to the all contacts. So these are the types of traffic we have: unicast, we have a broadcast, and we have a multicast. Same way, you have a unicast MAC address or unicast IP address. Unicast IP will be there, and unicast MAC will be there. Same way, you have a unicast broadcast IP and broadcast MAC address, right? And you have also multicast IP and multicast. So right now I'm sending what? I'm sending a ARP reply as a unicast. Once the PC1 will receive this packet, right? I'm talking guys, this packet. Once the PC1 A will receive this packet, what PC1 will do? PC1 first update the own information, right? ARP table, okay? The IP and the MAC. The IP will be what? 102 associated with the MAC address, what? B. Right? This is the information that we have, right? Once the PCA will update the ARP table, after that what? Now the PCA will create a ICMP request packet. So now again this packet will be created by the PCA, copy, paste it. And in this ICMP request packet, what happened? This is the ICMP request packet. Copy and paste. And in this destination MAC, what information I'm going to put? Now the destination MAC, I know the destination MAC is B, right? Associated with the 102. So 102, right? This 102 associated with the MAC address B, I can put the destination MAC is what? B. And now the PCA will send this ICMP request packet to the PCB. Once the PC will receive the ICMP request packet, what they will do? Now they will create a reply packet. Or in the reply packet, what happened? Paste. Now the PCB will create a reply packet, ICMP reply, right? Or in the reply packet, what happened? They will put the source MAC will be what? They will put the source MAC will be now B, destination MAC will be A, source IP will be what? 101 or 2, and destination IP will be what? 101. And now this reply packet, the PC2 will send to the PC number 1. And this is called as a successful communications. So if you have a look, right, if I'm going to summarize the way, can you see that the first ICMP packet has dropped, right? Just because of what? Encapsulation failed. And after that, what happened? The PCA will create a ARP request packet. It will send the ARP request packet to the PC number B. PC number will receive the ARP request packet. What they will do? They will update the ARP entry, right? After updating the ARP entry, what happened? Now this guy will give the reply packet. Once the PCA will receive the reply packet, they update the ARP entry. And now they will create a ICMP request packet. Why they will create the ICMP request packet? Because now they have a complete information. 10102 associated with the MAC address B. So now this packet is a complete packet. Now the PCA send the packet to the PCB. PCB receive the packet. It will create a reply packet, and it will give the reply packet to the PCA. This is called as a successful communications. This is how the communications is happening. Now, the goal is that what is the role of type field only? Guys, this type field is present in a Ethernet header, right? This type field is present in a Ethernet header. This is also called as a Ether type field. That is basically the 2-byte number, or we can call it a 16-bit, right? And what this guy is going to do, depend on the technology, right? Depend on the technology, this Ether type will be changed. Depend on the technology. Will be changed. Based on the this Ether type value, a data link layer decide. Based on the this Ether type value, data link layer decide, should I forward the packet to the layer 3? Should I forward the packet to the layer 2.5? And should I forward packet to the layer 2 itself only? If your packet is belong to the 0x0, right, 8 or whatever you call it, 0x0806, that is represent that it's a ARP, right? So it means that I don't need to, ARP is what? It's a layer 2 and layer 2.5 protocol, right? So in that case, what happened? No need to forward the packet to the layer 3. Because every layer, right? Listen to me, every layer has a information about above layer. It means that layer 2 has a information about, right, layer 3. Layer 3 has a information about what? Layer 4. And layer 4 has a information about what? Layer 7. So layer 2 has a Ether type field. Layer 3 has a protocol field. Layer 4 has a port number, and it will send the layer 7. And layer 7 has a services over there. Every layer has information about above layer. So if you have a 0x0806, it means what? It's a R packet. So I don't need to forward the packet to the layer 3. If you have a 0x0800, it means what? It's a IPv4. It means that I need to forward the packet to whom? IPv4. If you have a 0x8100, it's a I think so it's a 80.1q protocol, right? VLAN. So in that case, do I need to forward the packet to the layer 3? No, it's a layer 2 protocol. I'm not going to forward the packet to the layer 3. But if you have a 0x8147, that is called as a MPLS unicast, right? It means that what MPLS is going to rework on the layer 2.5, right? So it means that I need to forward the packet to whom? Layer 2.5. No need to forward the packet to the layer 3. Listen, guys, no need to forward the packet to the layer 3. I just need to forward the packet to the layer 2. If you have a 0x8148, it is called as a MPLS multicasting. So it means that I need to forward the packet to whom? I need to forward the packet to the MPLS multicasting itself on the layer 2.5. Same thing if you have a 0x86D something call as, right, I'm not 100% sure right now. It's a call as IPv6. So I need to forward the packet to the home IPv6. Just check it this thing, right? I think it's person over. So how ARP is a layer 2.5 protocol? How ARP it's defined on the layer 2.5 protocol. See, some books are referring to the layer 2.5 protocol, and some books are referred to the layer 2 protocol. So if somebody will ask you in the interview, just define it layer 2 protocol. If you have a look, I call as a Ethernet type, Wikipedia, and you can get the information from there as well, Ethernet. So basically this ether type is present in Ethernet header. Basically it's a present Ethernet header. That's a 2-octet field. 2-octet means what? It's a 2-byte, we can call it, and 16-bit. And if you see, they have a different ones. So IPv6 has a 860, I think so. I like what I do. Yeah, it's correct. And if you see 0x0806 somewhere, that call as a ARP as well as. So this is the MPLS unicast and multicasting, right? Lots of informations are there, right? If you see the VLAN tagging, the double tagging, we have this one. So single tagging will have a 8100 someone somewhere. Apple Talk, we have a different one. This ARP have 806 over there. 06 is ARP over there. And 80x00 is a IPv4. So this is present in your layer 2 header. It's not present in the layer. This is present in layer 2 header, and based on that value, this is the most important value, guys. This based on this value, the data link layer is deciding, hey, I need to forward the packet to home layer 3. So if you have a look, first also in the Cisco packet tracer, right, that how this thing is, how the packet is dropping, and how they are updating the ARP table. Then I'll show you the ARP header as well as. So let's say example, we have a PC1, PC number 2. Sorry, in layer to which protocol attached the Ethernet header to the packet? In layer to which protocol attach? Which protocol in a sense? Which protocol in the sense? I didn't get you the protocol. IP address 1, IP address 1 or 2. That's why I'm asking some this. Ethernet is a technology that I'm going to. It's not a protocol. Ethernet is a technology body. It's not a protocol. So I have assigned the IP addressing 101.1. I'll come to your question, right, Sandesh. Okay, 1 minute. A MAC address. So the MAC address of this guy, just write down over there. So check the MAC address of this guy. How do I check? I just go in the command prompt. I see the IP config /. So you can see the MAC address, also known as physical address. This is the 0E0. So I'm just going to write the first, okay, the first 4-bit digit, 00E0, right? And this guy, have a look. IP config /all. So guys, I'm just assuming you have a knowledge about how to, like, use the Cisco packet tracer. If you don't know this thing, let me know, or otherwise you can start your CCN again. So if you see, I have assigned the IP addressing on this guy, and if you have a look on the PC number 1, right, ARP minus A. Do we have any ARP entries over there on the PCA side? Nothing is there, right? Same thing if you have a look on the PC number 2. Do we have any ARP entries over there? ARP? No, there is no ARP entries, right? So what happened if you see there's no ARP entries, and if I'm going to ping from here to here, right? Send the traffic from here to here. Can you see that this ICMP packet has dropped itself by the PC? I'm not dropping this packet at the receiving end. Listen to me. And why they dropped the packet? Because the packet was not complete fulfilled, right? Because this was the packet, right? The destination MAC is not the encapsulation field, right? The packet is incomplete encapsulation field. And this is how the packet is dropping at the sender side, not at the receiving side. And now after that, what happened? Now this guy is going to generate the ARP request. And now this packet is coming to the PC number B. And what PC will do over there? It will first update the ARP. Can you see the PCB, right? 10101, that is this guy, right? And what is the MAC address of this guy? 00E0, right? I'll explain you what is the type over there. Don't worry about this thing. So now see how the PC1 is going to learn the MAC address over there, the destination side, based on the ARP protocol. Now this guy will give the word reply, and PC will receive the reply packet. And if you see now, this guy will update the, previously it was not. Now if you see, now we have on the PC1, we have a 102, that is this guy, right? A 00D0. And after that, what? This guy will send the ICMP request packet. And now this guy will give the reply packet. This is how the communication is happening. On the, make sure that the packet will be dropped on the sender side, not on the receiving side. Now, if you have a look, if I'm going to share with the little bit more detail, there's the JNS3 now. Okay, I can, okay, I have something project called as a PC to PC communications, maybe. PC ARP with static, not business. Come on. Okay, this is not I want. 1 minute. This is ARP test. Two routers I'm going to take over there, and change icon. I don't want like a distant one. Change simple, and I can go for the blue one router, and this is on. Yeah, so R1, R2, and R1. All good. And I'm just going to write on the IP. Okay, let me do one thing. Let me take a first console of this guy. R1, and we have our router motive as well. And let me guys just write down all the commands, okay, when I'm trying using this command, because you know this is the very important, because I can't say that okay, you have to write this command, this command, this command. This is your responsibility, right? So IP, I can, so the so MAC address, so interface 0/0. Let's check the MAC address of this interface, right? So MAC address of this interface, so interface 0/0. We have this guy, okay, copy, and I'll explain you the MAC address as right now my topic is different. Okay, right now I'm just trying to show you like how the PC to PC communication is happening, right? And the MAC address of R2. You can also check the MAC address by using this command. So interface 0/0 and include section, include BIA, burn in address, right? Burn in address. So these are the shortcut commands that helps you to troubleshoot the network. Okay, so this is the MAC address of B. And now let's assign the IP addressing. So let's do that interface 0/0. Okay, right now I'm just assigning the IP addressing. I'll explain you each and every command. What is the meaning of interface FA 0/0? What is the meaning of IP addressing? Right now, my perspective is just clear the ARP concept, right? Not the IP addressing. IP address, I'm going to assign the 101 and no shutdown and interface 0/0 because we have almost 1 hour of discussion of the assigning this command line. Okay, don't worry about that. 112 and no shutdown. So I have assigned the IP address of this person will be 101, and this is the class A IP addressing 1.0.0/8. That a concise way to represent the MAC address, and this is the 102. Or we can also call it a CIDR value. So if you see right now on the router side, show R, right? Can you see that we have on a router number 1, we just have only information. The protocol is what? It's IP protocol. It can be anything. It can be Apple Talk as well as. It can be Apple Talk as well as. So right now the protocol is what? IP. Address is what? 101. That's how this my address. Age is what? Age is just going to tell you how long, right? And how much time ago I learned this information. So this is my own information, right? I'm not learning this information. I'm not learning. This is my own information. That's why this value is an infinite value, right? There is no timer for the own values. Okay, if I'm going to learn the MAC address, right? If I'm going to learn the any ARP entries from my neighbor, then you will have some timer over there. If you're not going to learn, if you have a static entry or if you have a own entry, there is no any timers over there. And then after that, this is the hardware address, or we can also call it the MAC address of this particular interface. The technology that I'm going to use, that is called as a ARPA. Again, it can be changed. I'll show you, don't worry about that. Advanced Research Project Agency, and I'm learning this all this layer 3 and layer 2 information by technology ARPA on which interface. This is the interface of this guy 0/0. Same thing if you go back to the router number 2, and I can put the command show ARP. What information? Same information I have on side. The 102 IP addressing, the MAC address of this guy. Of course, I don't have a mind timer because this is my own entry, right? But do you have a neighbor information on the router number 1? No, because if I'm going to ping debug IP packet detail and debug ARP as well as, guys, just pay attention. It's important on R2 as well as, and capture this link so that I can show you the header as well as. If you see show ARP, if I'm going to ping 101.1.2, right, I just want to check the connectivity before extending the data, right? Whenever you're making a call to someone, what happened? First, you need to say the hello, right? And hello is what? Just check the connectivity. If you have a hello, okay, now they can extend the information. Same thing, I first need to check the connectivity, right? Do I have a connectivity between this guy and this guy? So once I say the 101.2, in that case, what happened? What is the source MAC address over there? Source MAC address will be C201, right? Destination MAC, I don't know. Type field will be what? 0x0800. That's the IPv4. Source IP will be what? 101. Destination IP will be what? 102, right? So this packet will be dropped just because of what? Encapsulation failed, right? So if you see, because I don't know the MAC address of this person, I just know the IP addressing. That's why I put the 102 over there. But do I have any idea of the MAC address? No. So what happened? This packet will be, first packet will drop just because of the encapsulation failed. I'll stop this guy now. And cool, right? So if you have a look, let me do one thing, view all and undebug all, right? If you see the router one, right, is generating the source IP address will be 101, that is this guy. Destination IP will be 102, and I'm going to send this packet from which interface? 0/0 from the routing table, RIB, routing information base. And this is the ICMP request packet, type is 8, that's called as a request packet. And if you see what happened, this packet is dropped just because of what? Encapsulation field, right? The size of packet is what? It's 100 bytes. You can change it as well, as we'll see that later on. But by default, the size of packet is 100 byte in the Cisco router when I send a ping. And this packet is dropped just because of what? Encapsulation field. Why? Because you are not fulfilling the information, right? The destination MAC is not there. And if the destination MAC is not there, what happened? I will drop the packet. This is the ICMP type 8. This is called as what? ICMP request packet. Once this packet will drop, what happened? Immediately, right? Immediately, the router one has creating the ARP packet, right? Can you see that ARP request? In the send request, what a source IP will be 101. Source MAC will be this guy, right? Of course. Destination IP will be 102. Do I know the destination MAC? Of course not. That's why I'm putting the 0000. And I'm sending the packet from which interface? 0/0. That is this guy. So if you have a look, I'll do one thing. I'll better to, I can put this information in the, in paint file so that you can analyze the things, right? I'll do one minute. Come on. I'll copy this guy to this guy till this point, right? Encapsulation field, now receipt. Okay, better to one. I'll take one more thing. Okay, come on. Show me something good. Till this point is good. Oh, good. So now everything is fine. And now I'll paste it in the paint file so that you can analyze the things. Right? All there. So if you see, the source, this packet is drop source IP, this 102, right? And this is the type 8, and this packet is dropped just because of encapsulation failed. And after that, what happened? The router has created the ARP request packet, right? ARP send the request over there. All good. And then after that, what happened? We'll create up. Once I receive the ARP reply, can you see that receiving the reply from the 102, right? So once R1 has sent the request packet, R2 is giving the reply as well as ARP reply. So that's, I'm getting the received reply 102. That's a MAC address C202. That's this guy, right? And if you see now header, what happened? Can you see that this part? R1, right? R1 is in the Ethernet header. We have a source MAC address C201. That's this guy. And if you see something called as well as LG bit and IG bit, don't worry about that. We'll see that later on. Okay, and don't make it right now more in depth. And destination MAC is a FFF is a broadcast, because ARP request is a broadcast packet, and type is what? It's a 0x0800. This means ARP, right? I need to forward the packet to whom? ARP. And if you see the ARP request packet, what we have information, the type is Ethernet 1, right? This is the opcode value. I'll do one thing. I'll take a screenshot and I'll paste it over there as well. As that will be good, so you can see better in the diagram. So this information I can paste over there. All good. So R1, right? So you can see that the hardware type is what? It's a Ethernet 1. This Ethernet value, right? This is called as a opcode value. This is called as a opcode opcode value, operation code, we can say that this opcode value will be changed depending on the technology. For example, come on. One minute. HCP, something good. No? Ah, all good. So if you see what opcode value we have, guys, where's my print file now? So the opcode, this is the operation code. It can be changed, right? Depend on the technology. Can you see that my technology is what right now? I'm going to use the Ethernet. So the opcode value is 1 over there. So same thing, if you see the different technology, we have a frame relay, we have a 15 over there, right? So some different technology have a different opcode values. This can be changed according to the technology. For example, a person has a different roll number, right? Of A has a roll number 1, B has a roll number 2, and C has a roll number 3, right? Then this is the packet is what? This packet is, yep, any questions? Okay. So this packet is, you can put your questions in the chat box if you have any question, because I muted yourself, guys, right? And that's because everyone is going to unmute yourself and they can speak also. This distraction is happening, that's why I mute all everyone. If you have a question, you can put in the chat box. Otherwise, I'll unmute you. So if you see, this is the request packet, right? And the hardware type is Ethernet, and the protocol type is what? It's a IPv4. Can you see that 0x0800? And this is the ARP over there. This is the 2-byte field, guys. This one is a 2-byte. Based on that, they are deciding, hey, I need to forward the packet to the layer 3 or layer 2 and layer 2.5, right? And hardware size is what? It's talking about the MAC address. The hardware are 6-byte, right? It's talking about the MAC address. And the protocol size, he's talking about what? It's talking about the IP, because IPv4 has a 4-byte, right? And opcode is what? This is the opcode is a request packet. Sometimes in your interview, right, they will ask you, how will you decide and how will you know that? How will the router know that and PC know that this is the request packet and reply packet based on the opcode value? This is the request packet, and that will be always unicast. So the request packet will be have opcode value 1, whereas the reply will be 2. The sender MAC address, I'm going to have a source MAC address of this guy, right? Can you see that the C201, because R1 is sending, and the sender IP address of this guy 1011. At the same time, I can point sender MAC address and the sender IP address of this guy 101. And target IP address is 102 because I'm pinging, right? Target IP, can you see the target IP is 102 because I'm pinging from the router number 1, and the target MAC address is set to the 000. So the sometimes also ask you in the interview, hey, tell me what is the target MAC address of the Ethernet header, right? And what is the target MAC address of the ARP header? The target MAC address of ARP header is 000, and the target MAC address of the Ethernet header is the broadcast. Why this thing is happening? Because your devices is going, your the middle devices, the switches, right, is understanding they will look up the packet, they will look up this information, not this information. That's why they are putting the destination is of broadcasting over there, right? And they are putting the destination, whatever the destination, because they have an ability to look the Ethernet header, not the ARP. The PC will look the PC and router will look the ARP header over there. That's why the target MAC is 00, because I'm looking for this person, right? I don't know who is this guy. I'm looking for the MAC address of this person. Tell me what is the MAC address. That's why I put the blank over there. You can assume like this is the blank value. And after that, what happened? This guy will give the reply. Can you see that? And if you have a look, I'll do one thing. I'll pick a screenshot and paste so that you can analyze the difference. Come on. And now it's good to go. Can you see? So any difference is happening? So according to the types of packet, the source will be changed, destination will be changed, right? The source and destination, this is the complete unicast packet. The still the type is a 800806 R2 byte. Only the things is that the R reply and the opcode value will be 2, except everything will be same now. And this is called as a complete unicast. Why I'm going to call this complete unicast? Because your layer 2 information is unicast. Can you see that? And even the ARP is also unicast. 101, come on, complete unicast. And here what happened? This is the broadcasting, the ARP request packet. Except everything is unicast, but ARP request is a broadcast packet. So this two information, after that, if you see, I'm sending what? After this two packet has done, right? The ARP request packet and ARP reply packet. So who has 102, right? So he's asking the C201, that's a source MAC address of R1, asking, hey, who has a MAC, who has a 102? He's broadcasting, he's asking, right? He's asking who is a 102. And after that, we have a echo request and echo reply. So by default, you are sending the 5 packets, 1 packet has dropped. So 4 packet is successful. Request reply, 1 packet, request reply, 2 packet, request reply, 3 packet, request reply, 4 packet. So your successful rate is what? 80%. So now if you see, if you have a look now on a router number 1, router 2 received the reply packet. Can you see that? It received the request from the R1. He has sent the request, and what R2 is giving? R2 is giving the reply. But before giving the reply, right, what happened? Reply, send the reply, right? So before giving the R2 reply, what they will do? Previously, they have only own entry, right? The R2 has a own entry. Now, can you see that? I learned the information. I'm present on router number 2 right now. 101 10 minutes ago, and the MAC address of C201. This is the MAC address of this guy. And I'm learning this information on which interface? 0/0. This is how your ARP, right? This is again, I'm repeating. This is I'm not done. We have a more almost 2 and 3 hours of the more class on the ARP, not the 2 and 3 hours, even the 5 to 6 hours on the more on the ARP class. I'm just giving you the overview how the PC to PC communication is happening, right? And what is happening in the background. So you can analyze this thing, take your time, and let me know if you have any questions in the basic one, right? Otherwise, I'll move to the more detail. Any questions in the basic one, guys? You can unmute you guys. If you have, you can. Rabarjan unmute themselves. Yes. Yep. You can ask them.
Hello, sir.
Yeah.
Sir, actually, I'm having one doubt regarding that ICMP request packet. Sir, actually, in CCNA, what I learned, in ICMP request packet, we are having the fields like source IP, source MAC, destination IP, destination MAC. After that, type and code.
See, I'm not telling you. See, I'm not sorry. I'm not telling you learn the wrong thing or bad thing. It's maybe you didn't understand the part, right? You layer 3, the ICMP. If you see what information they have, they just have a packet types over there, right? Not the source IP in the IP's information is present in the IP header. The MAC information is present in the Ethernet header. So we have 3 different fields. Can you see that? We have Ethernet.
Yes,
so Ethernet is saying that, hey, I need to forward the packet to home. It's a layer 3
800 version 4. Yes.
So I will forward the packet to home IPv4, and we have a source IP and destination IP address information. And now your ICMP packet, right? Your request packet is going to be encapsulated with your IP header. So this is your ICMP. They don't have any information like what is the source IP. They just have a header of the ICMP and they have a data, right? What you're sending your data.
Okay, sir. Thank you.
So they have a layer 2, like layer 2 information. They have a layer 3 information. Then after that we have ICMP. So this is the layer 2 information, source MAC, destination MAC, layer 3 source IP, destination IP, and then we have ICMP. So ICMP works on the layer 3. The protocol number.
Yes, sir. Okay, sir. Thank you.
Yeah, most welcome.
So if anyone asks how does ping works, means we can simply say ping works on ICMP protocol.
See, the first of all, the ping is what? If somebody will ask you what is ping, so first I'll tell you the history of that one. 1 minute. I'll tell you the history. Let me complete this. Do you have any question in the ARC one right now, the basic one? No. I'll explain you the what is the concept of ping over there. Clear?
Okay.
Okay. Now, guys, if you have a look over there on a router number 1, you have to just notice one thing over there, right? What R1 is doing over there? R1 is creating a incomplete entry. Okay, but this guy is creating a incomplete entry. But if you check on R2, are they creating any incomplete entry? They are just creating the entry. They are not creating an incomplete entry. So this guy has a complete entry. So understand one thing, your ARC header ARC entry, it can be a, please disable your mic, otherwise I'll again mute you. Okay, this is incomplete and this is called as a complete, right? Now, why the router 1 is creating a incomplete entry? The reason is that because when R1 is sending, try to understand this flow over there right now. When R1 is sending the packet, right? In this packet, we have a source MAC address will be C201, right? Destination MAC will be what? FFF. And then after that, we have a same thing C201. Destination MAC is what? 0000. The source IP is 101, destination IP is 102. This is the R packet, right? I'm requesting, right? So when I'm sending it, what happened? At the time, listen, at the time I'm making an incomplete entry. This means that what? I'm waiting for the reply. Waiting for the reply. So over there, instead of the hardware address, the MAC address I'm going to write over there, I'm just going to write the incomplete entry. For which person? 101 or 2. R2 will receive, and what R2 will do, they will update their entry, and that's why they are calling this guy as a complete entry, because they know each and everything. Once R2 will send the reply packet to the R1, and in the reply packet, what happened? They will put the own MAC address C202, that this guy, right? What R1 will do, once they will receive it, the reply, once R1 will receive the reply, what happened? They will remove the incomplete over there, and they will put the MAC address C202. If you have a look, see, I say the debug R, and say the ping, I'm pinging someone else, right? 103. Is this 103 is present in my domain, in this broadcast domain? No, right? So what happened? R1 will create a incomplete entry for this person. Am I getting the reply? No. So if I'm not getting the reply, what happened? Show R, can you see that? 102 has a complete entry. So in the hardware address field, right? What happened? I'm going to put the incomplete over there. I did not get the reply. I have sent the 5 requests to you, right? Five requests I've sent, right? I didn't get the reply. So if I'm not get the reply, what happened? I'm going to put the incomplete entry. And this incomplete entry will be valid for the 60 seconds. Just wait for some time. So 0 minutes is going on. 0, then 1 minute, 2 minutes, 3 minutes. So it will valid for the, see, it will be removed automatically. On. Can you see that? Now this entry is not there. So this entry, right, incomplete entry is just a valid for the how many second? It's just valid for the 1 minute. Incomplete means what? I have sent the request, right? Now I'm waiting for the reply. If I get the reply, then I will update the MAC address instead of and remove incomplete entry. If not, then incomplete entry will automatically remove after. And this process, right, that I have sent the RTQS packet to the router number 2, right, and router number 2 has give the reply packet, or in the case of PC, you can assume like this, or in the case of router as well as. Okay, so both you can assume like this in the case of PC and the router. So router 1 or PC 1 has sent the ARP request and ARP reply. What they are extending over there, this all they will update the ARP entry rate. They will update the ARP entry in the way of dynamic. And for the dynamic, we have some timer that is called as a 4 hours on the system. I think the PC, Windows PC has a 1 day. I'm not 100% sure. I'll forget it. I think the 1 day or 1 hour. Just check it on the Google. Cisco has a 4 hours. I'll let you know how to change this thing. I just informing you, right? This is a dynamic entry. You can also define as a static entry. For the static entry, there is no timer. For the dynamic entry, we have a timer that's of 4 hours. It means that after 4 hours, if the no communication is happening, after 4 hours, this entry will be plus out. So if you have a look, the default timer is what? Show interface 0/0 somewhere. Yep. This is our minute second. You can change this thing as well as. I'll let you in the comments. Don't worry about that. Okay, but this entry is a dynamic entry, and for the dynamic entry, we have what happened? We have a timer over there. So if no communication is happening for the 4 hours, this entry will be flushed out. You can manually flush out the entry as well as. What command I can use to manually flush the entry? Clear ARP cache. Cache is what? It's like a small memory where the all this entry will be present, right? This is the cache table. It's like a memory, right? It's like a storage things, a memory where the all the information is present. You can remove this guy. Just put the clear ARP cache over there. Now, I'll tell you this command is going to work on the real device, but on the GNS3, what happens if you see, we have entry. You see that? So better to do one thing, just flap this interface. Flap, shut it, and no shutdown. So now after that, what happens? So I don't have entry of the system. Do I have an entry of the 102? I don't have an entry of 102 right now. So again, if I'm going to ping, right? So do I have entry? No. So if I'm going to ping, right, 102, what happened? I will look up, hey, do I have a destination MAC? No. So let me jump to the ARP list. So your first packet will be dropped just because of ARP. Can you see? I'm sending the ARP request and the router number 2 is giving the reply. And I will update the again ARP. This is the dynamic way. Same thing in the PC side. If you see, you have a dynamic. And for the dynamic, we have some timer. For example, if you're not define the static entry, you can also leave it the static entry right now. Otherwise, we have to discuss something more as well as. So this is all about the basic things. Now let's come to the one question that the Vinay has asked, right? So ping, right? See, do you know what happened? On the time when the IP comes in the picture, right? Okay. IP is what? IP, it's like what we call over there. It's not a reliable protocol. First of all, IP is not a reliable protocol. IP is totally an unreliable protocol. It's not a reliable. And IP does not have a mechanism. Listen to me. IP does not have a mechanism to perform the error detecting or check the connection. They don't have a mechanism, right? To check the problem on the remote side. They don't have. It's just a protocol, right? That is going to encapsulate your packet. They don't have any mechanism to detect, okay, is there any error on the remote side or not? Okay, for example, let's take example. I want to send a packet from here to here. Okay, I want to send a packet from the PC A to the PC B. I will simply create a packet, right? Okay, we have a source MAC will be A, destination MAC will be B, source IP will be what 101, destination IP will be what 102. I will create a packet like this and send it. So in that case, what happened? Am I checking the reachability between this guy and this guy? By using the protocol IP, am I checking the reachability? No, I'm not checking the reachability. I'm just sending the packet. Listen to me. Whenever you're going to make a call to the someone, what you are doing over there, first of all? First, you are saying that hello. Hello means what? You're asking to the person, right? Remote side person. Hey, are you there? If the person is there, then you can, after that, once you receive the hello from the neighbor person, right? Then you can extend the data, right? Hello is very important, right? Whenever you're making a phone call or any like a Zoom session we are doing right now, right? So what happened when I came the first time, right? What happened? I said, good morning and hello everyone. Can you hear me? Why I'm doing this thing? I'm just checking the reliability. Hey, you guys are present or not? Otherwise, what happened if I come and give the session directly? Okay, if I'm not going to say the hello and how are you, I'm gonna start my I start my training. Then what happened? May or may not be you are listening or not. Same thing. IP is what? Just a protocol, right? They don't have any like the ability to identify the reachability things like is there any remote side problems happening like error detecting? No, they don't have anything. So what happened after that IP? They have introduced the ICMP protocol. Again, ICMP is not allowed, but they add some extra features in the ICMP, some message tab over there. They add it over there, and through the message tab, what happened? I'm just checking. Hey, are the remote side is present over there or not? So I'm sending a ICMP request packet to this guy, and he's giving the reply. If the reply is coming, right? If the reply is coming, it means that everything is working well. Now I can send the any HTTPS traffic. Any HTTPS or HTTP, whatever the traffic you want to send, you can send it now. But after getting the reply, but what happened? Take example, in middle of the router, right? They will just drop the packet. So what ICMP has an ability, right? What ICMP has an ability, if the router will drop the packet, now the router has ability to inform the PCA, hey PCA, I don't have a route. I don't have a route. For example, I'm sending a request packet of 8.8.8. So now if the router has an information, they can send the traffic to this guy, right? But if they don't have an information on the 8.8.8, what they will do? They can inform you, hey, I don't have information on the 8.8.8. So it means that they have an ability, right, to inform the error. Hey, something is problem, right? Please resolve these issues. So by using the ICMP, I'm just checking the connectivity. And in the ICMP, I'm going to use the command is what? Ping. Because ICMP is itself what? It's a protocol. By default, this protocol is enabled. But on the router side, what happened? What router understand? Router and devices only understand the command that you have to define the command. I'm dictating you, please do this task. Command is what? Command is like, I'm dictating you, please do this task. So ping is the command that works under the ICMP protocol. And by using this protocol, we are checking the error or not. So this ICMP protocol, whatever the masses we have in the ICMP protocol, all this masses is going to be encapsulated with the IP. So it's something like that. We have an IP now, and after that we have a ICMP. The masses, whatever the message you're going to, either again with the request message, reply, request, reply, the fragment masses like unroutable, lots of masses are there. I think so. RFC 792 is there, if I'm not wrong. I think the RFC 790 is for the ICMP. Let me check it. Okay, RFC ICMP 790 is. So they have a different masses. Can you see? Okay, I'll just open the RFC 792. So they introduced the ICMP protocol. Why? To just perform the error. So ICMP messages are sent in the several systems. For example, when a datagram cannot reach its destination when the gateway does not have a buffering capacity, if the router does not have a buffer, right? If the router does not have a memory, so in that case, what happened? The router need to drop the packet, and they can inform to the sender, say, hey, I don't have a memory, please resend the packet. So what internet protocol is doing? The internet protocol is not designed to be absolutely reliable. So by using the ICMP, what happened? I can get a feedback, right? So adding the ICMP with the IP, right? Adding the IP with the ICMP, it's still, this guy is not going to provide the reliability, but yeah, they can tell you what issue is happening in your network side. So this is the reason why they introduced the ICMP in the 1981, right? So can you imagine that in the 1981, this protocol has introduced, and this is the RFC that is written in the 1981. So we have a different types of message. Can you see that? Like you see that we have a something called type 3 has a what we call reply packet with the not reply. Destination at the source network is not defined. So we have different code network, unreachable host, unreachable protocol, unreachable port, unreachable. So different codes are there. Just have it. It's a max to max 20 pages of information. Just grab it, this one, and it will not take, I think so, half an hour. And that's a very important RFC is there. So by using the IP, guys, I'm not providing the reliability. I need a ICMP protocol. So ICMP works under the what? All the ICMP masses is going to be encapsulated with the IP. So ICMP masses are typically used for the diagnostic or control purpose or generated in the response to the error in the IP operations. So ICMP errors are directed to the source IP address. So he's informing to the source, hey, what error is happening? Like whenever you are booking something from the Amazon or the Flipkart, what happened? For example, if you are not pulling the complete address, for example, I just put the HSR or Bangalore. So they will call you, right? Hey, your address is missing. Can you give me the complete address? And you are giving the, that's what that is called ICMP. Can I understand now?
Yeah, I got it.
Okay, guys. Any other questions? Anyone? I'm not done with the ARP again. We have almost 3 to 4 hours more classes, right? Anyone has any questions about the ARP basic one? You can ask me. I'm done for the today.
Excuse me, sir.
Sorry.
Hello.
Yeah. Go on.
Sir, I had one doubt, sir.
Yeah.
Hello.
Yeah. Tell me. I can hear you.
Sir, Yes, I just texted you previously, sir, that in layer 2, which protocol attaches the Ethernet headers?
Which, that's why I'm asking which protocol in the sense, like what asking which protocol, मतलब मैं किस एंगल से बोलूं, मतलब कौन
Like
सा
in
protocol?
layer 3, मतलब in layer 3, IP attaches the IP header, right, sir?
So on the layer 2 we
In
have
layer 2, which protocol?
we have a Ethernet technology over there that we are going to attach over there in the to encapsulate the like your masses. Like in the previous, it was a frame relay as well as now we have Ethernet header. It previous the frame relay, it was the ATM as well as. So this Ethernet technology we are using for the adding the all the source
That
MAC, yeah, all the source MAC and destination MAC information. Previously it was the frame relay, right? Like we have
Ethernet
a this,
technology.
we have this kind of
Yeah.
hardware type we are going to use over there. This amount of hardware type. Again, I'm not understanding your question, right?
Yes,
You're asking protocol. You're saying that you are like you are correlating with the IP, like the IP has a source IP and destination IP is going to be is added in the IP header. So in that case, I'm explaining you, right. So in the source MAC and destination MAC is going to be added in the Ethernet. On the serial link, we don't have a MAC address concept, so there's no Ethernet header is happening on the serial link.
Mhm.
Okay, in ping 4 packets are sending, is it default? Shall we increase or the size? Yeah, definitely, Venkat, we can increase that. We'll see that. Don't worry about that. I'm not done. Okay, I just give you the basic overview of the like how the communication is happening, right? We have almost, I'll explain you each and everything over there, like whatever the default size and how many packets they will send. But in ping 4 packets, no, it's depend on the scenarios. All cool. Anyone has any other questions?
Sir, what do you mean by ARPA, sir? Like it is a protocol or also?
ARPA is a technology,
ARP.
right? Wait for the tomorrow, then you will understand that ARPA concept. Wait for the
Okay.
tomorrow.
Thank you, sir.
We have almost, I think, so 70 pages of the one docs over there, the Cisco docs. I will explain you all the everything over from there. Don't worry. We have lots. I'm not done of the ARP. Okay, we have lots of things right now. Encapsulation ARP. Yeah, actually, encapsulation ARP. The experience is asking what is ARP. So multiple types of encapsulation. So we have that. We'll see tomorrow. In the Ethernet technology, for the right now understanding, in the Ethernet technology, we are going to use the ARPA. And nowadays, we only using the Ethernet, not the serial link.
Oh.
All good, guys. So quick info as well as, so if you are not there in the WhatsApp group, just ping me on this number. I will add you in the WhatsApp group. Okay. And from there, you can download the videos. Please don't clear the videos. I'll add the books as well as over there, right? So you can download from there. So ping me on this number. I'll add you in the group and put the questions in the group if you have any doubt. And just mention your name and batch stamp CCNP. That's it. And if you have any query, you can make a WhatsApp call to me. Okay, don't bring a normal call.
So the dynamic ARP entry will remain for 4 hours, right?
Yeah, we have a static entry as well as.
Yes. For the first 3 hours, if we did not have any communication, so if after the 3 hours we have some communication, so the timer will again start from 0,
Refresh,
or
yes.
it will
No,
get
I
refreshed.
don't. It will not start from zero. The Cisco. It will
Okay.
not start.
Okay.
I think so. It's refresh, right? I'll check it. This thing, right? Don't worry. I'll check the docs on because
Okay.
according to the Cisco, it's not refreshing, but in the docs I have seen that it's refreshing as well as. Let me check it. No, I'll let you know.
Yeah, sure.
Because on the GNS3 it's not, maybe the real device is refreshing. I haven't checked on the, I forget that on the real device. When I accessed it the last Corona, almost 1 year happened.
Yeah, okay. Fine.
All good, guys. So hope I'm clear to all of you. If you have any query, you can ask me. Otherwise, see you tomorrow. Have a great night. Bye-bye.
Bye, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, guys.
You too.
Thank you. Mhm.